Welcome back. Today we're going to be taking a look at some 3D measurement, and we're going to be taking a look at 3D measurement by taking a look at the volume and surface area of square-based pyramids and cones. So let's go ahead and take a look at a few vocabulary terms. So a few vocabulary terms we need to know. Volume measures the capacity of an object, or how much an object can hold. Surface area measures the total area the surfaces of an object occupy, so the front, back, bottom, top, all those added together give us the surface area, and we can use formulas to calculate the volume and surface areas that we're going to be taking a look at today. So let's go ahead and take a look at example A. Here we are at example A. It says Hasbro is attempting to package the new Transformer figure. How much space is inside the box? So we've got a picture of the box that they want to use for this Transformer figure. We need to ask ourselves two questions. One, are we finding volume or surface area? And two, what kind of shape do we have? So we know that since they're telling us that we're looking for how much space is inside the box, we know that we're going to be looking for volume. So we're going to need a formula for volume, but we need to figure out which formula we need, so we have to take a look at our shape and see which one we have. So I see that it comes to a point at the top, which lets me know it's either a pyramid or a cone, and then I notice that the base is not a circle, so it's not a cone. And it is a square-based pyramid. You can see that because both the length and the width are 6. And although it doesn't look like it's drawn to be a square, we need to be paying attention to the math, not what the picture looks like. So now I'm going to take a look at my handy dandy formula sheet, and when I do that, I'm going to see the volume formula for a square-based pyramid is V equals 1/3 big B times H. So big B is a new variable that we haven't seen before, and big B stands for area of the base. So whenever you see the capital letter B, that's standing for the area of the base, and that's very, very important. It doesn't mean that our base is just going to be 6. It means that the area of the base is going to be whatever the shape of our base is, we're going to be finding the area. So let's take a look and plug in the things that we have and see what things we need to find. So we know that we're going to have volume equals V. We don't know what that is. They've given us the 1/3. Now we don't know what big B is, so we're going to have to calculate that. So big B being the area of the base means we're going to need to calculate the area of the base of our square here. So our area formula for square is side squared. So we're going to be doing 6 squared. 6 squared is 36. So our big B in this case is going to be 36. Now, if it was a rectangle shaped base, we'd be doing the rectangular area formula. If it was a triangular shaped base, we'd be doing the triangular area formula. But since it's a square, we're going to be using the square formula, side squared. So let's plug that into our formula now. Our big B is 36. And taking a look at our shape here, we see that our height is 10. So we're going to plug that in. Now, since this is multiplication, we could just multiply these numbers all together. 1/3 times 36 times 10. And when we do that, we get 120. Now, remember, we need to label our answer. So we're talking about centimeters here. As we can see, our entire picture has centimeters. And since we're talking about volume, we know that means cubed. So how much space is inside our box? 120 centimeters cubed. Now let's take a look at example B. So here we are at example B, and it says Hasbro is now attempting to wrap their new package for their Transformer figure. How much paper will they need? So again, just like last time, we have a couple questions to ask ourselves. One, is this volume or surface area? Or two, what kind of shape are we dealing with? So since we know we're going to be wrapping around the outside of this shape, we know that we're going to be talking about surface area. Then we need to determine what kind of shape we have. So again, it's pointy at the top, so I know it's either a cone or a pyramid. I don't see a circle around the bottom, so it's not a cone, so I know I have a pyramid. So I'm going to take a look at my surface area formula for a pyramid, which is 1/2 L times P times B. So we've got a couple variables in there that we haven't seen recently. So the L is going to stand for slant length. The big B we talked about before is the area of the base. And then the P, hopefully you remember from our 2D measurement unit, stands for perimeter. If not, I'll link a description to the video below to talk about perimeter. So now that we know that we're talking about a pyramid, we know what slant length is and the area of the base, let's plug in the things that we know and solve our problem. So we don't know what surface area is, so we're going to start with that by writing out SA, since we don't know what the surface area is. We do know what 1/2 is, so we're going to go ahead and put that down. Now we need to take a look at our slant length. So again, that's not going to be the height, which is straight up and down. Our slant length is going to be the length of the side. In that case, it appears to be 5. So our slant length is 5. We need to know what our perimeter is, so we're going to be adding up all the sides along the bottom. That's how we find our perimeter. So we have one side here, one side here, one side here, and one side here. Since we know this is a square, all the sides are going to be the same. So to calculate our perimeter, all we're going to be doing is taking the side that we've got, so 8 is our length, times 4 for the 4 sides. So 8 times 4 is going to be 32. So that's our perimeter. And again, if you don't want to multiply, you could always just do 8 plus 8 plus 8 plus 8, and that will give you the same answer. So we know our perimeter is going to be 32. Now we need to add our big B, so we got to figure out what our big B is. So again, that's going to be area of the base. Since my base is a square, I'm going to be grabbing my area formula for square, which is side squared. Our sides are 8, so we're going to be doing 8 squared, and 8 squared is 64, so that's going to be my big B. Let's plug that 64 in. Now, again, this time I can't just multiply across. I have to follow the order of operations. So I'm going to do some multiplication first and then some adding. So 1/2 times 5 times 32 gives us 80. So then again, we have SA equals 80 plus 64. And then we can just do some addition from 80 plus 64. And that's going to give us a surface area of 144. Now again, we have to label our answer. So since again, we're going to be talking about centimeters here, we've got centimeters all over our problem. We know it's going to be centimeters. And then since we're talking about surface area, we know we're going to be using squared. So that is our final answer. Now let's take a look at example C. Here in example C, it says the volume of the square base pyramid is 588 cubic inches. The height of the pyramid is 9 inches. What is the area of the base? So in this case, we have no picture, but we have some information in our problem that's important. So let's go ahead and take a look at it. The volume of the square base pyramid is 588 cubic inches. The height is 9 inches. What is the area of the base? So it looks like in this case, they've given us some information, and we're going to have to work backwards. So first, we're going to need to figure out what our formula is. And since we're talking about the volume of a square base pyramid, like it says, we're going to need our volume formula for a pyramid, which is V equals 1/3 times B, big B times H. And remember, big B stands for the area of the base. So let's just bring that in here as well so we don't forget. All right, so now let's plug in the information that we have. So we know that our volume in this case is 588. So the good news is they gave us our volume to start. We know what 1/3 is, so we can go ahead and plug that in. They did not tell us the area of the base. That's the thing we're missing, so that's going to be our variable. We're missing big B. And then they told us the height is 9 inches, so we can go ahead and plug that in. So now that we have that all plugged in, it looks like we're going to be doing everybody's favorite thing, solving an equation. So we need to start by multiplying all of the things we have on the right-hand side. 1/3 times big B times 9. So 1/3 times big B times 9 is 3B, because we don't know what the B is. Bring down our 588, and now we need to solve our one-step equation by dividing both sides by 3. And when we take 588 and divide it by 3, our final answer is going to be 196 equals big B. Now again, we have to label our answer, so our area of the base is going to be 196 inches, and it's just going to be squared since we're talking about the area of the base. So remember, it's important to match the units to the thing that you're talking about. Area gets squared, volume gets cubed, everything else just gets normal units. Now let's take a look at example D. So here in example D, it says Emily is making a container out of plastic. How much plastic is needed to construct this container? So again, we have our two famous questions. One, is this surface area or volume? And two, what kind of shape do we have here? So since we're talking about making this shape out of plastic or having all of the plastic that we need for the shape, we know that this is surface area. So now we just need to figure out what type of shape we have. We can see it's pointy at the top there or at the bottom because it's upside down. So that's either a cone or a pyramid. And this time I do see a circle around the bottom, so I know that I have a cone. So I'm going to go ahead and take a look at my surface area for cone formula. So my surface area for cone formula is surface area equals pi r squared plus pi times r times L. Hey, wait a minute. L, we know what L is. We've seen L before. L is our slant length. So let's not forget that and plug in the information that we have. So we don't have surface area, so we're going to be looking for that. We know what pi is. In our case, we're going to be using 3.14. Our radius is going to be half of our diameter. So looking at our cone here, it looks like our diameter is 10. So I need half of that, which is going to be conveniently 5, and then I do know what squared is, plus pi, which again is going to be in our case 3.14, times our radius, which we just talked about, is 5, and then I need to take a look at my slant length. Now remember, that's not the one that's going to be going straight up and down, that's called height. The one that's going to be going along the side is this 13 centimeters. So be very careful that you don't mix up the height and slant length. That's a common mistake. All right, so now we're going to plug in our 13 and work our formula. So again, we have to be following the order of operations. So we're going to have to be doing everything on the left, then everything on the right, and then we can add them together. So on the left-hand side, I have to do the 5 squared first because exponents before multiplication. So 25 times 3.14, and that's going to give me 78.5. So surface area equals 78.5. Plus now I've got to do everything on the right-hand side, but lucky for me, that is just straight multiplication. So 3.14 times 5 times 13 is going to give me an answer of 612.3. So now that I've got those two pieces together, I can just do some adding. So 78.5 plus 612.3 is going to give me a surface area of 690.8. And again, I have to look for my measurement here. Looks like we're dealing with centimeters. So centimeters, and since we're talking about surface area, centimeters squared. So that's our final answer there. And let's move on to example E. So example E says Erin is making snow cones. She needs to fill this paper cone with ice. How much ice can the cone hold? So we're trying to figure out how much ice can go inside the cone before we put the little ice on top, figure out the extra cost of that. So we need to figure out two things. Again, volume or surface area, and what shape it is. Well, good news is they talk about making snow cones, so we're pretty sure that our shape is a cone. Also, I see a picture of a cone here, so we know we're dealing with that. So then we just need to figure out, is it volume or surface area? Since we're going to be filling this particular cone with stuff, we know that means that this is volume. So now let's take our volume formula for cone. Taking a look at my formula sheet. I've got V equals 1/3 pi times r squared times h. So let's put in the information that we have. So we're going to be taking a look for V. So we don't know our volume, we do know 1/3, and we do know pi. Pi is 3.14. And now we need to take a look at our radius. Luckily they gave it to us, so our radius is 8. Don't forget to square it, and then times our height. And again, they threw us two numbers here, our 17 and our 15. But since we're taking a look at the height, we want the one that goes straight up and down. So that means we're going to be using our 15. So plug that in, and luckily this is straight multiplication. However, we need to do this exponent first before we can do that straight multiplication because we need to remember our order of operations. So again, I don't know what 1/3 is, times 3.14, times 8 squared. 8 times 8 is 64, times 15. Now I can put that all straight in my calculator, and when I do that, I should get a volume of 1004.8, and again, I need to have some sort of label. We're talking about centimeters here, and since I'm talking about volume, it's going to be cubed. Now let's take a look at the last example. So here in our final example, it says the surface area of the cone is 432 meters squared. The diameter of the cone is 16 meters. What is the slant length? Round your answer to the nearest tenth. So we need to remember to round our answer. Now let's go ahead and pull some important information since I don't have a picture to look at. And it says the surface area is 432, so that's important to know. The diameter of the cone is 16, that's important to know. And we're trying to find the slant height. So it looks like we're going to be working backwards like we were before. But the good news is they already told us we're working with surface area. They already told us we're working with cones. So we can just grab that formula for surface area of a cone that we've already used. Pi r squared plus pi times r times L. Not sure what L means. Oh, right, that means the slant length. That's important to always have. So now let's go ahead and plug in the information that we do have. So we're going to have surface area. Oh, wait, we do already know our surface area, so we don't have to worry about that. Our surface area is 432. It's going to be equal to pi, so our pi is 3.14, times our radius. They didn't give us a radius, but luckily for us, they did give us our diameter. Our diameter is going to be double whatever our radius is, so take our 16 and cut it in half. That's going to give us 8, so our radius is going to be 8 squared plus pi r, so pi, so again we've got 3.14 times our radius, which again we just found was 8, but then we don't know our slant length. That's the whole point of this whole thing. So let's go ahead and put an L there since we don't know that. All right, now we're going to work the order of operations and do everybody's favorite thing, solve equations. So let's start by multiplying these all together. So we got to remember to use our exponents first. So 8 times 8 is 64. 64 times 3.14. It's going to give us a 200 at 0.96. Remember, this is all going to be equaling 432 when we're done. And then we have to multiply the other side together. So 3.14 times 8 times L is going to be 25.12 L. Again, we don't know what L is. That's what we're doing here. So now we need to solve a two-step equation. So the first step there is to get rid of my constant. So I'm going to subtract 200.96 from both sides. So 200.96 from both sides. These are going to cancel, bring down my 25.12 L. 432 minus our 200.96 is going to give us a 231.04. And then our final step here is divide both sides by 25.12. We're going to do that on both sides of our equation. So again, 25.12. These are going to cancel. Bring down my L. 231.04 brings us that divided by 25.12. It's going to bring us 9.197, on and on and on. Okay, bad news. That number didn't come out evenly. Good news, they told us to round by the nearest tenth. So taking a look at our number here, I'm going to find my place, look next door, 5 or greater, add one more. So it looks like we're going to be going up one. So we're going to end up with a slant length equaling 9.2. And again, we need our measurement here. We're talking about meters, and this is just a regular length. It's not area, it's not volume, so it's just going to be meters. So luckily for us, we found our slant length, and that brings us to the end of this problem and the end of this video. So if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.